Assuming stable coke oven operation and consistent volatile matter for coal charged into the oven, the composition of chemical byproduct yields would be determined by coal maceral components. In the foreseeable future, chemical byproduct yields in the coking industry, especially liquid products such as tar and crude benzene, will increasingly become a core factor deciding the operating performance of coking enterprises. Let's start with vitrinite. Vitrinite sees the greatest structural shifts for byproduct formation. When the vitrinite reflectance of coal reaches around 1.2, its oxygen content gradually declines, while the carbon-hydrogen ratio rises, and the yields of tar and crude benzene hit their peak values. This highly aligns with the metamorphic degree, featuring maximum oil generation when exploring petroleum from a geological perspective. With further metamorphism, gas output rises relatively, yet tar and crude benzene yields drop. If metamorphism continues deeper, all chemical byproduct yields decrease. Next, let's talk about liptinite. Liptinite delivers the highest chemical byproduct yield among all coal macerals. From its formation stage onward, liptinite contains high hydrogen content and low oxygen content, with nearly 100% volatile potential. During coking, liptinite not only generates chemical byproducts itself, its abundant hydrogen can also help retain volatiles from other macerals in liquid products. Finally, we look at inertinite. Inertinite has undergone oxidation or carbonization during its formation. In the coking process, it only produces a small volume of gas and barely yields other chemical byproducts. After mastering the core characteristics of each coal maceral, we can adjust coal blending formulas according to price fluctuations of coke and chemical byproducts, or actual product demand. First, under the premise of identical coke quality and unchanged coal blending cost, we should prioritize coals with tar and crude benzene yields within the peak yield range. Second, select and adopt coals rich in liptinite. Third, avoid coals with high inertinite content.